Hello again. Here we are at section 7.2, which talks about the no-choice theorem, and AAS, which some of you are probably wondering when we were ever going to get to that postulate. Well, here it is. Okay, so first of all, let's talk about the no-choice theorem. It says that if two angles of one triangle are congruent to two angles of a second triangle, then the third pair of angles are congruent. Okay, well, that's cool and everything. Why does this work? Let's take a look at this example. So we have one triangle here that have angles measuring 20 and 50. And then we have a second triangle that also has angles measuring 20 and 50. So this is the two angles of one triangle, these two, are congruent to the two angles of a second triangle, those two. We have no choice but to say that these third angles are congruent. Well, let's think about this. 20 and 50 add up to be 70. So if you subtract 70 from 180, that means this has to be 110 degrees. Obviously, my diagram does not match up with that, but we'll go with what the numbers say. Okay, so same thing over here. 20 plus 50 is 70. 70 from 180 was 110. So these two angles ended up being the same measure. So that is the no-choice theorem. Pretty sweet, huh? Okay, so from the no-choice theorem, they were able to come up with this last remaining postulate to prove triangles congruent. And that is the angle side. So we would have this angle congruent to that angle. We would have another angle, say this one here, congruent to that one up there. And then the side that they're talking about is either going to be this side or that side. It's not going to be the side in between the two angles, otherwise that would be angle side angle. So let's make it this side with that side. Okay, so why would we be able to use angle side now that we know the no-choice theorem? Well, basically what they said, somebody along the lines, said, hey, we've got this no-choice theorem that says, hey, if these two angles are congruent to those two angles, then we have no choice but to say that this third angle here is congruent to this third angle. And lo and behold, you would now have angle side angle. So they decided, well, why do we have to do all of that? Why can't we just come up with a postulate that says angle side? That's what they did. So when you guys go to do a proof and you want to use angle side, you don't have to use no-choice theorem. Chances are you're probably not going to use no-choice theorem in any proof. But it is there for you anyway. Okay, so let's go take a look at a proof and how we would do this. So they give us that MR is perpendicular to KP. MR, KP, all right, so perpendicular right there. And then KO perpendicular to PM, so these are perpendicular, awesome. Okay, then they say that angle RKM, this big angle, is congruent to angle OMK. Okay, we're trying to prove that our triangle RKM and triangle OMK are congruent. All right, so let's see. We've stated our givens are given. If we know that we've got perpendicular lines, we know that we have right angles. So KRM and MOK are right angles by definition of perpendicular. And we also know that right angles are congruent. Okay. And I don't know why this says definition of right angles. That is absolutely incorrect. But I don't feel like restarting my video to fix that. You guys all know that that reason is by the definition. No, not by the definition, by all. Let's see if I can write this. All right angles. Woo. Congruent. Ha ha ha. I was able to beat the system. Okay. There we go. So we have all right angles are congruent. And so now what we can say, since we have this angle and that angle, we've got this angle and that angle, all we need is this remaining side here, which we can use by reflexive property. Here we go. So let's put that in there. Now we have angle, angle, side, and we can prove the triangles are congruent. Okay, that's it. So yes, this section you will have some proofs that you'll have to do. Sorry, we're almost done with proofs, but that's all we have for this lesson. Hope that wasn't too bad.